and we're now ready to simulate. So, Tools, Run EDA Simulation Tool, EDA RTL Simulation. RTL standing for Register Transfer Level. And this will run ModelSim. So the folder, or library I should say, we're interested in is Work. And if we expand this, we'll see that Quartus has already compiled MyXOR, and we can see its sole architecture, MyXOR version 1 there. Now the test bench is not there, and that's because it's not been compiled yet, so we need to do that. Compile, and conveniently there it is in the current folder. Click Compile, you'll see outputs down here, and a change here. Done. And now we see MyXOR VHD test. We can look at each of these by right-clicking and selecting Edit, and the test bench, and it's the code we looked at just now. So ModelSim actually has its own editor as well, and in fact, for a lot of the time you'll probably find it more productive to work directly in ModelSim. Now, the VHDL we wish to run under simulation is the test bench. It's this simple process block that generates the input stimulus. So let's do that. Simulate, start simulation. To work, it's the test bench. We don't choose anything else along here because we're not doing timing or anything like that. And we click OK. Now this has opened another panel, and you'll notice you haven't just got the source files now, you've got some others, and it's the wave that we're interested in. Now, a quick way to do this, click on the entity of interest, which is the test bench, and drag it onto here, and you'll get A, B and Y appearing. We can now run the simulation until it ends. And it's when it hits that last wait statement it'll stop. So we click Run. Pressing the minus key will allow us to zoom out, and we'll see that's a simulation. If we want to look at the output, Y had a value of 1. So you've got to get the cursor in the right place. So that is a simple functional test. When you've finished, simulate, end simulation. Now you can either go back to Quartus, or we could do some more work to our test bench. And I'm going to do that now. I'm going to run that test again using a slightly different approach. And this is where you will actually see the benefits starting to show. So I'm going to paste in some code that I wrote earlier. I'm going to indent it properly. So now we're going to use a for loop. Count starts its life out at 0 at the beginning of simulation. And then A is count of 1, B is count of 0, count equals count plus 1, wait for 20 nanoseconds. But I've put it inside this for loop, and it's going to do this 4 times. So we don't have to write the lines out over and over again. So with that, we need to rebuild the test bench. So compile. That's the VHDL test file. No errors. And again, we can simulate. However, it still doesn't bring up the signals on the waveform, so we still got to drag them across and click the Run button. Again, we're going to need to zoom out to see this. And this time, we should finally get the same result. So, functionally, we can see for 0, 0, the output 0, 0, 1, the output's 1, 1, 0, the output's 1, and 1, 1, the output is 0. So the exclusive OR is functionally correct. Let's stop the simulation. close ModelSim. Say yes, and import any changes. So we actually see our test bench reappear. So that's using a for loop to automatically generate test inputs.